Yeah, thank you, Agriculture Information, for giving me this opportunity to speak on a very important topic on maintenance and fertigation aspects of drip irrigation. This is the second to my series, which I had initially spoken about the why drip irrigation is necessary. And the second most biggest challenge is actually the maintenance part. So I'm very happy to be here and I thank the organizers. The topics to be covered in this training will fall under the following categories. What is chemigation? Meaning, when we buy a drip system, we have to maintain it correctly. So, how do we apply the water soluble fertilizers? That is called fertigation. And how do we periodically maintain the system so that the system gives you a life of at least minimum 3 to 5 years? And how to actually, what are the equipment that is actually used in the field to carry out these procedures? And another challenge that is there with the farmers is the which are the water soluble fertilizers which are commonly used in fertigation, and how do we go about this acid treatment. I am going to illustrate this with one example of a 1 acre plot, and the maintenance and the other challenges like insect and rodent damages I will be illustrating with the help of some photographs from the field. So this I had already spoken to you last time. This is the typical layout of a drip irrigation system. You know that every drip irrigation system has got three main components. One, all the components near the water source is called as the head control unit. So that is basically the basic one. And then you have, from the water is getting filtered and getting into the drip irrigation system, it passes through the water carrying system, which is basically a network of pipelines called the main and submain. And then the water is distributed through the distribution system into the inline and online drip irrigation system. So here I had spoken about this at length, all the components, and I want to emphasize particularly on the Ventury, which is the main component which is going to be used for fertigation and our maintenance part. And all of us know that drip irrigation is a very precise method to apply water, fertilizer, and pesticides slowly, frequently, and directly to the root zone of the crop. So you are seeing two interventions that are there commonly practiced in the field. The one on the left, that is the inline drip irrigation system, which is generally used for the closed space crops like sugarcane, vegetables, turmeric, cotton, maize, etc. And the online drip irrigation system, which is typically used for the wide space crops like coconut, arecanut, mango, citrus. You name any horticulture crop, it gets covered. So all these I had covered in my previous session. Just to get the connect between the earlier one and the present one, I'm just showing these slides. Now, I had explained this also. This is how the head control unit, this is where we are going to actually do the injection of the fertilizers and do the after sales treatment. And this is a typical head control unit. As you can see, we have the bore well. From the bore well, the water is actually passing through a system of components. I had explained all this. Here, I would want you to focus only on two components, that is the Ventury and the throttle valve. The throttle valve is used to create the pressure difference between the inlet and outlet. And through the Ventury, this water is, this fertilizer which is kept in this bucket is going to get injected. So for you to understand how the Ventury works in a very simple way, it's like actually you have a glass of water and you want to drink juice. You could maybe directly drink it, or you could put a straw and then suck it. So basically this Ventury works on the principle of suction. So basically it is going to suck the fertilizer that is over there, and we are using only water soluble fertilizers. So let me talk about what is chemigation. So we are actually applying chemicals. So chemigation is a broad term which simply means applying all water soluble chemicals through the micro irrigation or drip irrigation system. It has got three parts in it. One is the fertigation, which is the most important part, the water soluble fertilizer. The second one is the acid treatment, because you will have to provide dilute acids to clean the system. And finally, even now, pesticide, water soluble fertilizer, pesticides also can be applied. So all this, since we are applying chemicals, it is called a chemigation system. What are the advantages? It provides uniformity. Like chemicals are going to go along just like how water is going to get distributed uniformly throughout the entire field. Whatever chemical or the fertilizer that you're going to apply is going to be uniformly applied. And another problem in the hand broadcasting, when you apply fertilizers by the farmer, what happens? You have to walk on the field, and you will actually be walking. When you walk, you actually compact the soil. So there is chemical soil compaction. And this, since it is going through the drip irrigation lines, there is not going to be any challenge of this. Another big advantage will be that the quantity of water soluble fertilizer or the chemicals can be reduced conveniently by 20-30%. Results have shown that you can go for a, you don't need to go, for example, if you want to have a 50 kg urea to be applied, you can maybe manage with a slightly lesser quantity because you're not going to broadcast it everywhere. It's going precisely to the root zone. Another, of course, added benefit will be the pollution of the environment is also decreased because you're applying reduced quantity of chemicals. And of course, like drip irrigation, major advantage is the labor and energy saving that is there. And just like how water will get distributed, even the chemicals also will get easily distributed everywhere uniformly. So now the next thing is, what is fertigation? Fertigation is nothing but the application of water soluble plant nutrients directly through the irrigation system. Every word here is important. Water soluble nutrients, because today a lot of farmers are doing what we call as organic farming, and they're applying fertilizers which are not water soluble. In this connection, I will be giving you the list of the fertilizers that can actually be applied. What are the equipment that is commonly used by the farmers? Like I already showed you the picture of the Ventury. That is the main equipment that is used. And then we have what is called as a bypass or a fertigation tank, and followed by fertigation pump, which is generally used inside greenhouses or shade nets for protected cultivation. So this is the first method, that is the Ventury or the fertigation, which is generally used for acid treatment as well as for the water soluble. So I have shown you this and I have explained it earlier, but for the benefit of those who might have joined now. So the Ventury basically has two functions. One is you're going to apply the water soluble fertilizers into the drip system, and also you can inject the acids that are required to keep the safe upkeep of the micro irrigation system. So which are the sizes which are available in the market? Very commonly, we can actually, it is available for very small plots. We can go for the 1-inch Ventury, which has got an injection rate. What is injection rate? How many liters of fertilizer will get into the drip system per hour? So it varies between 250 to 300 liters per hour. And any obstruction that is put on a pipeline will create what is called as a head loss. You have a head loss of between 0.4 to 0.6 bar, but you need a minimum pressure of 1.5 kg or 1.5 bar at the inlet so that the Ventury will operate. If you are having large areas, then generally farmers go for the 2-inch Ventury, which has got an injection rate of 600 to 900 liters per hour. And since the size is higher, naturally the head loss also will be higher. The biggest advantage of the Ventury is the fertilizers that are applied, the concentration remains uniform throughout. But there is a small disadvantage, that is the head loss. Of course, nowadays the Venturies are designed very well, and this is actually now not an issue at all. So how does the Ventury work? So this is a schematic diagram explaining the Ventury. So this works on the principle, the Bernoulli's principle, which many of you may be aware. So you have, this is the inlet side, this is the inlet side, and this is the outlet side. And when we create the pressure difference between the inlet and the outlet, the fertilizer gets sucked in. Like I gave you the example of the drinking the water or the juice from a cup with the help of a straw. So the pressure difference, so here what happens is the pressure, inlet pressure, and this is the outlet pressure. The pressure in the inner side is higher and in the outlet side is lesser. So how that is created? By the throttling. And when the pressure difference is created, automatically you can see that the fertilizer is getting injected. And what are the advantages using the Ventury injection? It is, one is it's very low cost. It has a very low maintenance. There are no moving parts or mobile parts. The concentration remains uniform. This is one of the major advantages of the Ventury. It does not require any external source of energy, and the same pump that is used to drive your drip irrigation will also drive your Ventury. It is very much lightweight. It can be dismantled. It can be kept and can be used whenever required. It can suck the fertilizer solution from an open tank, and it is very conveniently adopted for automation, like automation irrigation systems also it can be adopted. Of course, every product will have some limitation. In case of the Ventury, you have what is called as a head loss. Whenever you throttle, there will be a pressure loss, which is of course factored into the design. And it is a little bit sensitive if there is pressure fluctuation due to voltage fluctuation. And it is definitely not suitable for solid fertilizers. And some of the conditions that are required is you need to have a good pressure in the system. If the pressure is not adequate, then you may have to go for a booster pump arrangement to give the required pressure. So to get the constant pressure, only then your fertilizers will get injected at the prescribed rate. The second method is the bypass of the fertilizer tank. The photograph you are seeing, actually, this is a drip irrigation system having fertilizer tank. The water is actually being fed by gravity. When there is a low head available for the system to work, that time it is suggested to go for a fertilizer tank. And again, here also you have to create the pressure difference between the inlet and the outlet side. Fertilizer tanks are available in many sizes like 30 liter, 60 liter, 90 liter. So this is very conveniently adopted by many farmers, particularly when the borewell output is very less and the pressure is very less. You can go in for the bypass or the fertilizer tank. And the bypass or fertilizer tank, as you can see from the sketch, when you actually throttle in the center, what will happen? The fertilizer that has been put, for example, if you have put in urea inside, it will get totally mixed up and then it will mix up with the water and then it gets into the drip irrigation system. The main advantage in case of a fertilizer tank is you have very minimum head loss. So wherever you have a condition where the head loss or the pressure available is very less, you can go for a fertigation tank. And the disadvantage is that whatever concentration you start in the beginning, it continues to vary. You don't have a uniform concentration. This I will explain in the next slide. See, when you start the concentration in the graph, it's very, very high. So as you go on fertigating, because this problem gets circumvent and then finally you have this problem of concentration getting tapered off. So initially the concentration will become high and later the concentration becomes actually less. So this is one drawback in the fertilizer tank. So summarizing the advantages, it has got again a low head loss, low maintenance. It's very simple to operate. It is suitable for applying water soluble fertilizers. It does not require any external energy source. You're going to use the same pump. Only quantitative fertilization can be done. The concentration is not uniform. It is affected by change in water pressure, like I told you. The main disadvantage is the concentration varies from the beginning to the end. It has got limited portability. Unlike in case of a Ventury, which is lightweight, this has got limited portability. It's quite heavy, the thing. This is not generally adapted for automation. And we generally we cannot do acid treatment with this because the tank could get corroded with the help when you are going to apply the acids. So just to give you what I mean by the difference between applying through a Ventury and applying through a fertilizer tank, the one on the left actually is the fertilizer tank, where you can see that the fertilizer concentration is the highest at the beginning and then slowly goes on decreasing. Whereas in case of a Ventury, the concentration that you have prepared in the master tank remains constant throughout. So that is the main advantage. As you can see, the water and fertilizer will get uniformly injected into the drip irrigation system. Then this is the third method, which is actually the fertigation pump. And these are basically a little more expensive compared to the other two methods. And these are very, very much used inside greenhouses, protected cultivation, where you require a high degree of precision to control the electrical conductivity and the pH of the water, as well as what you want to apply to the particular plant or flower or vegetable that is there inside the greenhouse. So these are the three methods that are there generally used for the fertigation. Now we'll have to look at the list of fertilizers that are actually suitable for fertigation. As you look at the sketch, you will find generally the fertilizers which are white in color and free flowing. So you all know that the three major fertilizers are NPK, nitrogen, phosphorus, and potassium. And the one on the right, what you are seeing is actually the red phosphorus, and bottom is the DAP. Those are generally not recommended because that will actually create clogging in the emitting system and they are not fully water soluble and they are best avoided. So coming to the what are the fertilizers which are really suitable for fertigation? They should have a very high nutrient content in the solution. When I mix it, it should get almost 100% salt dissolved, and should be for field temperature, it should get dissolved, should be fast dissoluting in the irrigation water, should be of a fine grade so that there is no clogging of emitters, and it should be also be compatible. What happens is you will have fertigation and there are fertilizers that you cannot mix at one time. So that is one thing you have to take in care, and there should be minimum interaction with the irrigation water, and there should not be a drastic variation in the pH of the water. And of course, it should be the corrosivity for the control head and system. Of course, this is taken care, but nevertheless, these are the desirable qualities of the fertigation. Now, let us look at the list of the nitrogenous fertilizers which are generally used in fertigation. So we have the very commonly used urea, which has got 46N00, and potassium nitrate. These are very commonly adopted. And then you have 19-all. You have all the other ammonium sulfate, urea ammonium nitrate, ammonium, monoammonium, ammonium phosphate, calcium nitrate, magnesium nitrate, all fertigation grade today in the market, very easily available. So all these nitrogenous fertilizers can be very conveniently adopted. Coming to the phosphorus fertilizers, we have on top of the list, we have phosphoric acid, which has got 0,50 to 0. That is, phosphorus will be at 52. The advantage of using phosphoric acid, it will not only take care of the maintenance of the drip system, but it all, along with being a good fertilizer. And then, of course, we have monopotassium phosphate and monoammonium phosphate. These are the other preferred phosphorus fertilizers which can be used in fertigation. And coming to the list of the K fertilizers that are there, mainly we are using potassium nitrate and potassium chloride, 0,060 or 13,046. And of course, some of these fertigation, the liquid fertilizers are generally not adopted in India. We must understand the difference between water soluble and liquid. Liquid fertilizers are tailor made, which actually comes in a big tank and it is made to the ratio that is required. Water soluble fertilizers are available in solid form and they can be mixed, readily mixed. To check whether fertilizers are really compatible in water, you can do a jar test. Take a little of that fertilizer, put it into a jar and stir it well. And once you keep the jar at one place, there should be no sediment at the bottom. So if it is meeting that condition, then generally it is a water soluble fertilizer. So that, because even though they tell, there could be some filler material. Another important point that we need to keep in mind is the pH importance for fertigation. So all of us know that the 7 is neutral, the pH scale 7 is neutral, 0 is acidic, and 7 to 14 is alkaline, 0 to 7 is actually acidic. So here, most of the major and minor and macro and all the nutrients, as you can see from the chart, whether it is phosphorus, nitrogen, potassium, these are all actually very easily available in this particular range of 5.5 to 7.5. So this is the favorable range of the pH which is generally suitable for fertigation. Now we will come to a very important topic. So till now we saw all the fertilizers that can be used. Now we will come to the maintenance of the acid treatment. So there are 4 basic questions we need to answer. Why should we do acid treatment when I'm having so many filters? Which acid should I apply? And how to apply it and when to apply it? So let us understand this. See, acid treatment, basically what happens, you are seeing the photographs of how the drippers, these are the inline emitters, how they are getting clogged. And what will happen is, even though you are filtered, water contains dissolved salts. So to remove the dissolved salts in the irrigation water, which are precipitated over a period of time, what will happen? The water, when you are switching off the drip irrigation system, the water will evaporate and the salt gets precipitated on the outlet. You can see how it has got a white deposit, or it could even get into the labyrinth if your filtration is not good. Generally, if it has got a white color deposit, it is usually of calcium or magnesium. If it has got a brownish red, generally it is of iron. And if it has got a greenish color, it is due to algae. So these things generally tend to clog the micro irrigation system. So which are the acids we can apply? Hydrochloric acid, that is the most cheapest and commonly used acid, and very easily available in the market. In the market, when you go to a hardware shop, you can ask them for a bathroom cleaning acid. They will easily lift it and give. But of course, the concentration may be around 28-29%. It's okay. Phosphoric acid is one of the most preferable one because it is also a water soluble fertilizer and helps to clean the drip irrigation system. Nitric acid, generally we are recommending, and the concentration is around 65 to 75. Only if there is a severe blockage after you have treated your product with hydrochloric acid and still the blockage is not coming out, then we are recommending the nitric acid. Sulfuric acid is pretty high concentration used in batteries, generally very difficult to handle. Generally, this is not recommended, but there are some cases where this also can be utilized. The next question is how much acid to apply. So the correct way to come to know about the quantity of acid that is required is basically a field titration. That means how much acid should I add? How much ml of acid should I add to a liter of water to bring down the pH to 2 to 3? Because we are going to acidify and see that all the salts that are there inside, it's like cleaning your bathroom which has got a lot of salt. So basically you are going to clean all the salts. So let us now understand with a small example. All of us know that vegetables, generally the inline drip irrigation system is used, and I am considering a spacing of 4 feet or 1.2 into 0.6. And the length of drip line in 1 acre, as all of you know, 1 acre is 4,047 square meters. If you divide it by 1.2, you will get 3,300 meters of drip line. And how many emitters will be present in that drip line? I'm assuming that you have a 16 millimeter, 2 liter per hour and 40 centimeter drip line, which is very commonly used. If I divide 3,300 by 0.4, I would get 8,250 drippers. And we know that each dripper is a 2 LPH dripper. So you require 16,500 liters per hour in case you are going to do the acid treatment for 1 hour. Definitely you're not going to do it for 1 hour. So actually when we see after the titration, what we start is we take the water, we check its pH, and then we start adding the small ml either by a syringe or by a filler. And say, for example, in this particular case, about 1.5 ml was required to bring down the pH to 2. So that means 1.5 ml was required for 16,500 liters. So, if you multiply the two, you will get 25 liters. This is for 1 hour. Generally, if you have gone for a 100 liters drum and you are using a 300 liter Ventury injection, so roughly around 20 minutes is the time required. So that means the quantity of acid you need to get ready for that 1 acre will be 25 divided by 3, because 20 minutes is nothing but one third of an hour. So basically 25 by 3, so 8.33 liters per acre. So with the help of the Ventury, valve by valve, suppose you are having 4 valves, you have to inject this particular acid, keep that acid water inside the drip line for about 12 to 24 hours. Suppose you did the acid treatment today in the morning at a particular time, the same time tomorrow morning you can go and flush out all the end caps, the flush valves, and whatever calcium, magnesium, salts, whatever is there, everything will come out. The color of the salt will give you an idea what could possibly be the challenge. It could be, if it is iron, it could be brown in color. Usually if it is white, it is calcium and magnesium. So here exactly I'm showing how we are doing it actually. So we are actually checking the pH with the pH paper. We have to bring down the pH to around 2 to 3. And you are seeing the white deposit of calcium and magnesium and the white precipitate. And therefore, once you have reached that required level, so you add 1 ml, then check, then again you add a little more, and then you come to the calculation. So this is very easily done and very practically we have demonstrated. And after this, what happens? Your system becomes as good as a new system and it will run for many more years. So now I just want to take you to the last part, that is a safe upkeep of drip irrigation system with the help of some pictorial illustrations. We all know that we have a number of filters. I'm showing you all the 3 types of filters actually. So whenever the filter has to be cleaned, you can see on the left side, the cartridge inside the mesh has to be taken out and you have a running water and you have to clean it up. So here you just have to just put in the water and the mesh gets automatically cleaned. This is a hydrocyclone filter that is there. And it has got a collection chamber. And what happens, hydrocyclone works when the water has a lot of sand impurities or silt which has collected down. This thing outlet has to be open till you get clean water, you can have it flushed out. So similarly, you can open up regularly and daily you need to open only this drain valve, and only then you have to just do the inspection of the filters regularly. So this is about the filter part. And very important to ensure that you have proper pressures in the field. And like I told you last time about the inline drip irrigation system, we generally go for a disc filter. So the disc filter also is very easy to clean. And once the filter is clean, you can see how well the inspection is being done. And here, whatever different particles that have been collected, so all that you have to inspect. So this is one farm which we did in Chamarajanagar. When we opened up, we found a lot of muck. So once the farmer had installed this, he has never even opened the thing once. So then we told him that you have to open it up, otherwise the hydrocyclonic effect is never there. So the filter will not work properly unless you are cleaning just like if you have a vehicle and you don't want to do it, you have to change the oil once in 3 months. So similarly, you have to take care of your drip irrigation system, which is often neglected. And of course, the end pressure checking is very, very critical. At the end of the drip line, like I told you, the drip irrigation in the last webinar, that you need to have the required end pressures. So if the pressures are right, that means your drip system is working correctly. If there is a difference in pressure or something has happened, that very clearly shows you that there is a blockage or there is some other problem. So this is what. So we give you a portable gauge at the end of the drip line. You can apply this gauge and check out the required pressures that is stipulated as per the guidelines. And then of course, every drip system also has a pipe at the end which has got a flush valve. The flush valves are open and all the unnecessary particles are cleaned out, and you can see the person and the farmer also, they are removing all the muck, and this is to be done periodically. So if this is done, what will happen? The system will remain well intact. So this is a schedule that I'm suggesting, that we are generally suggesting for all our farmers. If you have a screen or a disc filter, you have to clean it daily. So that it just takes hardly 5 to 10 minutes. Just open it up, check for any impurities, clean it and put it back. And if you have a sand filter, then you have to go for a back flushing. That is, you have to just reverse the flow and ensure that all the algae that has collected is coming out. And of course, you have to walk along the field and see that the inspection of the drippers and the drip lines. So this has to be done twice a week. And whenever you commission flushing of the drip line is very important. On commissioning of the system, you will find that you are going to have the lot of when you have drilled your pipeline, a lot of plastic debris would have got into the pipeline that has to be flushed out. So twice every month you can go for the other treatments, and also the acid after every acid treatment, it is a good practice. You have to flush out all the unwanted muck as well as the material. And acid treatment, generally we recommend that once in every 3 months or as and when it is required. If you find salt blockages happening, then you can go for phosphoric acid treatment, because then the farmer is not worried that he's also getting a fertilizer injection. The last part, that is, again, you have certain places now in the field, a lot of damages happening due to insects and rodents. So generally, I'm just showing you by the sketch. So you are finding that some tubes get bent and something is ruptured. So actually, these are all things that are happening, and people claim it to be a manufacturing defect, when actually it is not a manufacturing defect. So you have actually the problems of the different nature. So let us understand. So this is another photograph where we had opened up the drip system and the dripper, and you can find how the button inside or the insert inside has got totally chewed off. So when we further investigated in the field, it was basically ants that were actually chewing up the inner part of it. So how do you take care of such things? You must actually go for some kind of a spray of chemicals, and that is the only remedy that we can suggest at this point of time. And you will also find in certain places some, particularly some, not only ants, even rats and squirrels, and some places even peacocks seem to make a lot of marks on the drip irrigation line. And it's difficult. It's very easy to relate how this the jar, it is looking pretty aggressive, and how it actually is going to make these marks on the drip irrigation line. These are actually defects created by nature. These are not manufacturing defects. And finally, how do we take care against all these insect damage and things? The best thing is to have a real storage at the end of the crop season. So what you do is, the drip line are all foldable. So at the end of the season, rather than laying the drip lines on the field, we would request you to put it on the reel and roll it up and keep the drip lines carefully for the start of the next season. So this way, what will happen? You're extending the life and also keeping the entire thing in very good shape. So this is the safest and easiest method, and we at Premier Irrigation definitely will be able to support you on these activities. And this is what you are actually seeing on the storage of the drip tubing for a very good life of minimum 5 to 7 years. So thank you very much for the opportunity given to Agri Information, and I'll be more than happy to take any questions that are there. I hope I've completed within the stipulated time of 30 minutes, madam.
Yes, Mr. You have completed on time. Yeah. And very nice presentation, and thank you for a very detailed presentation. Now I'll take up the questions posted by our participants one by one.
Okay.
And the first question is, if a farmer has an existing drip system, is it possible to add a fertigation unit to the existing drip system?
Yes, it is definitely possible to do that. Our field engineer or site engineer can visit, and we can definitely, it's possible to add a fertigation system. Just a small fittings will be required. We just have to make an arrangement such a way that we can add this fertigation system, because now in the current guidelines, the having the Ventury is a compulsory item. You cannot have a drip irrigation system without a Ventury, because you cannot maintain the system, nor can you apply the fertilizer. So definitely that is possible. Yeah, I hope I have been able to answer the question. It is possible to do a retrofitting, what you're asking. Yes.
Okay. And the next question is, Mr. Vijay, can you just stop sharing your screen?
Yeah, sure.
Yeah. Next question is, What is the cost involved to add a fertigation system to an existing drip system? Is this covered by subsidy?
It will not be covered by subsidy if you are putting it later, and the cost of adding a complete unit may be in the range of 8,000 rupees, but only if you want to have the Ventury and just the throttle valve arrangement. I think within around 4,000 to 5,000 rupees it can be done, provided you go. There are different sizes of the Ventury. You can go for a, if you're going for a small area like a 1-inch Ventury can be used, then the cost can be even further. Definitely we can do that.
Okay. And the next question is,
Yeah.
where to get help to find out which soluble fertilizers is useful for different crops?
Water soluble fertilizers today in the market very easily available, and they are all, it will be written on the bag, fertigation grade. Okay, I have already shown you the list, but of course I could have maybe possibly shown you a photograph showing the list of the thing. Today in every fertilizer market, there are two types of fertilizer. One is called as the straight fertilizer, which may or may not be water soluble, and then you have the water soluble grade, which is easily soluble, and that it will be written on it. And like I told you, to ensure that it is really water soluble, you can carry out the jar test. You can take a little quantity of that fertilizer in the shop itself, ask him to give you a small quantity, put it in the jar and mix it up and see if once you mix it up, all the fertilizer should dissolve. That means it's really a water soluble fertilizer.
Okay.
Yeah.
Yeah. And next question is, in your experience, what type of farmers are using this system? For average farmers, is all this a little complicated?
No, sir. It is really not complicated. It is the most simple system. Actually, in fact, now the government of India under the Pradhan Mantri Krishi Sinchai Yojana, which is there in all the states across India, we in fact this Ventury is given as a standard arrangement. So that it is really not a problem, I think. And installing it or even doing any kind of an arrangement is definitely not a problem, and it is not expensive at all. And I think like if you buy a vehicle and if you go, you have to go for service, like changing the oil, changing the fertilizer. So this is definitely, it can work. There is no problem at all.
Okay. And the next question is, in our farm, peacocks are damaging the drip irrigation pipes, which are exposed. Any solutions for this?
Yeah, this is a challenge which is there. Like I can give you an example where we had this problem with rodents. So why does the rodent come? Let us understand, why does the rat or the rodent or the squirrel come? In summer, what happens? They come in search of water. So I saw one very innovative thing applied by a farmer. So basically he had kept a number of earthen pots in the field, small open shallow pots, and he had filled it up with water. So he was providing the water to the animals that were coming. So if you provide the water, to a large extent, it will get curtailed. The second other thing is, okay, how many places the peacock is going to come? Maybe a 5-10 places. You just have to cut over there and you get a simple joiner, which hardly costs you 2 to 3 rupees. So you will be having a maintenance cost of maybe 50 rupees or 100 rupees a year, which I think is very, very affordable by anybody. And because nothing comes, like nothing is totally, like even if you buy a vehicle, you have to change the oil, you have to go and do some servicing of some part which is worn out. Compared to that, the expense that is going to come in this for a few joiners is going to be very, very minimal. So I'm sure it's not an issue at all. It can be easily done. Yeah. Any other question, madam? Hello?
Yeah. Next question is,
yeah.
What is the average life of drip irrigation system? What is the general maintenance required and expense involved?
So the government of India has stipulated the minimum life should be 3 years. And in fact, it is up to 5 years. If a farmer has used a system for 7 years, he is eligible to go for another system. So that is the first point. What was the second question, madam?
1 second.
Yeah.
Maintenance. It's about the maintenance.
Maintenance, yeah. General maintenance, like I told you, I had given you the schedule. The maintenance has to be done on a weekly basis. There are some, like the filters and all, have to be cleaned daily. And then There are other schedules like which have to be done on at least on the fortnightly basis, and some can be done once in 2 months or 3 months. That is the acid treatment. So that schedule, I think I had shown it in my presentation.
And what is the expense involved?
See, the expense that is going to be involved is only the cost of the acid that you are going to buy. For example, you saw the example. So you'll just need to buy the acid. For example, if you are going to buy hydrochloric acid, which is roughly around 25 rupees. So 25 into say 8. So that's it. So it's hardly about 200 rupees is the cost of the acid. Other than that, that is only for the thing. Otherwise, maintenance, when maintenance is done, if there is some small spare parts are there, some joiners or some leakages or something are there, then that will be charged as per the thing. It is really, I mean, you compare to the cost of a drip system, it is not even less than 0.1%. So it's a very, very small percentage. And the point that I'm driving again and again is that if you want your system to last for a long time, the maintenance has to be done regularly. So if you take care of your system regularly, it will give you a very long life. So most of the time we have seen in the field that people don't maintain the systems and they expect some magic to happen. You just laid the drip irrigation system, you don't want to maintain it, and then you think that the system is going to work well. That is definitely not going to happen.
Okay. And the next question is, does the irrigation subsidy vary from state to state? Drip irrigation subsidy?
Yeah, the drip irrigation subsidy is governed by the government of India, and the respective states have different subsidy norms and subsidy guidelines. So that we will have to go to the local horticulture or agriculture department which drives the scheme. But basically for the subsidy, the Pradhan Mantri Krishi Sinchai Yojana has given the what is the indicative cost. The indicative cost is generally given, but then there can be like certain states follow certain prices. Like for example, in Karnataka, they follow the Gujarat prices. Like that in different states it is there. And like in Maharashtra, you have an open pricing system. So that you will have to refer specifically to the state. But the subsidy is usually calculated based on the indicative cost given by the government of India.
Okay. And next question is, what percentage of farms in India have drip irrigation system? Any studies on this?
Yeah, number of studies have been made on this. In fact, state-wise, it's available. If I take, I can categorize India into 3 parts. One is the category A state, the category B state, and the category C state. Category A states are those states where the drip irrigation is quite popular. So if you take an average of that particular state where this drip irrigation is popular, like Karnataka, Tamil Nadu, Maharashtra, the percentage can vary anywhere. Adoption can vary from 10 to 15%. But if I come to a category B state where the adoption is still in the nascent stage, the percentages are much lower. And if you take India as a whole, and if you take a category C state like West Bengal or some of those states where the adoption rate is low, so overall there it could be around 6 to 7% or even lower. So on the whole, Indian average, if you take maybe 7 to 8% in the states which are still adopting micro irrigation, which is the necessity, and the states which have already adopted, you can have exceptions in certain states where it could be even more than 15, 20, 25%, where the water is very scarce. Like if you go to Rayalaseema area in Andhra Pradesh, the percentage of adoption is more than 30, 35%. So it is like that. So it is very specific to the region.
Okay. And next question is, what is the right method of fertilizer application?
The right method of fertilizer application, I have shown you 3 methods actually. I had shown you the Ventury, and then I have shown you the fertigation tank, and then I have shown you the injection pump. The Ventury is the system which is promoted, and also for the main reason that you're going to get the fertilizer in a concentrated form. So therefore, the Ventury is the most recommended system. But if you are doing your fertigation inside a greenhouse, then where you require very precise control, there you will go for a fertigation pump, or you will go for a unit which has Venturies, which are again automated. Fertilizer tank is only recommended because it has got a non-uniform concentration issue. It is only recommended in places where the pressure from the water source is very, very less. So suppose you put a Ventury and it does not work. In such cases, possibly the fertilizer tank will work, because the pressure drop across the fertilizer tank is only hardly 0.2 kg per square centimeter. That is the reason the government of India, and way back in 2003 when they started the scheme, they actually promoted the fertilizer tanks, but then they realized that farmers were not mixing the fertilizers and the concentration was varying. So therefore, the government changed it from the fertilizer tank to the Ventury. So to answer in one line, the Ventury is the most preferred and suitable method of injection because your concentration is uniform and it is very economical and cheap to the farmer. And also there is no maintenance or no moving parts in the Ventury.
Okay. And this is okay. Does the irrigation company also helps with annual maintenance?
Most irrigation companies actually don't. I mean, everybody is expected to follow an irrigation maintenance schedule. In fact, as per the government, various state governments, you have a maintenance schedule that is to be followed. But this is an often neglected area by many companies. But we at Premier, we definitely take pride in doing this. We are doing extended services to all our farmers, which is called as Krishi Seva. We in fact visit our farmers who have actually install the systems and do a servicing free of cost to them so that they are benefited. We actually guide them. We try to get into them a sense of responsibility that you have to maintain the system. It's just not enough that you have a drip system, but you have to maintain it. Any equipment that is purchased has to be maintained.
Okay. Yeah. And next question is, should fertigation in last half an hour of total irrigation period or during total irrigation period?
A very nice question. Whoever has asked it, basically is asking how the fertigation should be run. So there is what is called as a 15-30-15 rule. What is the meaning of that? When you switch on the drip irrigation system, the first 15 minutes you will apply water. After that, you will start injecting the water soluble fertilizer for 30 minutes or 40 minutes. And after that, again, you will apply 15 minutes of plain water. Why? Because you don't want to have any of the sediments being left in the drip irrigation system. The initial 15 minutes, basically you have to wet the soil because the fertigation has to get into the root zone. So therefore, it should not be given in a concentrated form. So when you dilute it and you already have some water, so that the concentrated fertilizer is not getting into that root zone area. So therefore, 15-30-15 is the rule generally recommended, is the general ratio. It could be 15-40, 15 minutes of water, 40 minutes of fertigation, and another 10 or 15 minutes minimum of running plain water, so that any sediment, anything that is there, everything gets out of the emitter or through the end line.
Okay. I think now we have a last question. I'll just read it out.
Okay.
Just 7 to 8% drip irrigation adoption. Just 7 to 8% drip irrigation adoption average is low. So there is a lot of potential for drip irrigation in our country.
Yeah, definitely there is a lot of, this is the message I want to give the entire audience, that we are sitting at the tip of the iceberg. If we don't save water, water will become a commodity which we may have to show in paper for our future generations. And saving water just to save ourselves, and as I told you in my first webinar, that the world population is moving at such a rapid rate, and by 2030, population will overtake that of the China, and we will become the most populous country. And if we don't adopt these water efficient methods, we are definitely going to be a problem. Already we are seeing the water scarcity in cities like Bangalore, Chennai, and many other cities where the water tables, which were 300, 200 feet, have gone even up to 1,000, 1,200 feet. The water extraction is so high. So water is being extracted at a faster pace than what water is coming into the aquifer. So this is the challenge that is there. And it is mandatory in many states like Gujarat, for example. If you want to get an electrical connection for your borewell, you must adopt a micro irrigation system, either a drip or a sprinkler irrigation system is mandatory. I think such kind of interventions for every state will go a long way in promotion of this particular water saving technique, which is actually adaptability. For example, if you take Israel, is more than 80% to 90%. So we would also, we are moving in the right track, and under our Prime Minister Modi's vision, definitely most of the states have been given a lot of funds, and I think definitely this should happen.
Okay. Let me check. Yeah. Now we don't have any further questions, and I think now we have come to the question round. I also posted your contact information with our participants, so they can directly reach out to you in case they require any further help from you.
Okay.
And now we have come to the end of question round. Agricultureinformation.com likes to thank our speaker, Mr. Vijay Kumar, for taking the time to talk about this subject and with a very detailed presentation. And I also like to thank all the participants for joining this meeting. The meeting will now be closed. Thank
Okay,
you all.
madam. Yeah, thank you, madam. Thank you very much for the opportunity. Yeah.
You're
Okay.
most welcome, sir.
Thank you. Thank you
you.
for your team also, because they've coordinated very well and kept in touch and did all the requisite. So I wish Vadamale Publications many more such things, and I will be happy to conduct many more such webinars, one per month maybe, because many topics are there, and I would like to help the farmers. So that is what is our Chalo Banaye Mitti Sona logo. That is from our Premier Irrigation. Thank you very much.
Sure, sir. We'll keep in touch with you. Thank you.
Thank you.